We're going to talk about some special cases of factoring. And whenever you look in a textbook or something, it says special cases and it gives it special words. But it's really not. Here's what I want you to remember. These are patterns. And truly, everything in factoring is looking for a pattern. And when we were doing trinomials, we looked for a pattern of what multiplied to the constant, what added to the middle. That was the pattern that we were looking for. So now we are going to look for some patterns that when they happen, oh, your life is so much easier. Everything just works out so much easier. So let's look at this pattern. So let's start by multiplying and see if we can come up with the pattern that will help us go backwards. All right? So if I am multiplying, x times x is x squared, 5 times x is 5x, x times negative 5 is negative 5x, and 5 times negative 5 is negative 25. And if I add everything together, I have x squared, I have 5x, I have negative 5x, and I have negative 25. Well, look what happens. What is 5x minus 5x? That's 0. So what really happened is, if I even look up here, I didn't even have to write it down. What is 5x and 5x? 0. These cancel each other out. And so all I'm left with is x squared minus 25. Now, is that what we usually see? Don't we usually see 3 terms? So what's my first key here that something odd happened? Well, number one, there's only 2 terms, isn't there? Something happened to the middle term. Well, why did the middle term disappear? It was because one was positive and one was negative. And what happens when you have a positive and a negative? Something disappears, doesn't it? Well, let's look at the other one. It's let's practice and see if the exact same thing. X minus 6 and x plus 6. Okay, so we have a negative 6 and a positive 6. Let's see what happens. What's x plus x times x? X squared. Negative 6 times x, negative 6x. X times positive 6. And negative 6 times positive 6 is 36. And look at that right there. What happens right there? A negative 6 and a positive 6 is gone. What's left is x squared from right up here and negative 36. So we have discovered a pattern that is really powerful. If you have the same factors, only one is positive and one is negative, the middle terms are going to disappear, and all that is left is your first one and your last one. Now, there's one more thing in this pattern that you need to understand. It only works for subtraction. It only works for subtraction. Well, let's see if we can handle this. We have x squared minus 9. What do we notice? Only has 2 terms. Only has 2 terms. The middle's gone. There's no x term. There's no linear term. The middle is gone. This is subtraction. So I bet I can use a pattern. Well, the pattern is, how do you get x squared? You get x times x. How do you get 9? 3 times 3. So my factors must be x plus 3, and what? X minus 3. They have to be opposite. One has to be positive, one has to be negative, but other than that, they have to be exactly the same. So this was an XX, this was a 3, 3, so x plus 3, x minus 3. Now let's check to see if it worked. Let's put x plus 3 and x minus 3. X times x is x squared. 3 times x is 3x. X times negative 3. And 3 times negative 3 is negative 9. Now, do they cancel? Yes, they do. 3x minus 3x, they're gone. And so what do I have? X squared minus 9. Isn't this a great pattern? Because you're not even going to have to work hard for this. So let's see if we can think through some of these. Now, do they have two terms? They do. They have two terms. The middle term is obviously missing. There's no x term. There's no linear term. And are they squares of something? Look at 81. Is 81 a square of something? Yep. 9 times 9. How do you get x squared? X times x. If this is x times x and this is 9 times 9, what do I know my factors are? X plus 9. And what's that second one? X minus 9. They have to, one has to be positive. One has to be negative, because that's what makes the pattern. If you don't have one of them positive, one of them negative, that middle stuff is not going to cancel, and there's no, it doesn't work, does it? All right, let's look at this next one. Well, I know the 25 thing. That's 5 times 5. But this 4x squared, anybody got any ideas? Well, to get x squared, I know x and x. What two things can I multiply to get 4 that are also exactly the same? They're a perfect square. So that's 2x and 2x. So does 5 times 5 equal 25? Yes. Does 2x times 2x equal 4x squared? So what are my factors? 2x plus 5 and 2x minus 5. So it works with even weird numbers and all sorts of numbers. It does. All right. Well, I know this 16. 16 is just 4 times 4, isn't it? I got that. X to the 4th. How do you get x to the 4th and they're both the same? Oh yeah, I went back to my exponent rules. And if I am multiplying the same base, I add the exponents. If I multiply the same base, the shortcut is to add the exponents. So x squared, that's x to the 4th, isn't it? Well, now I know what my factors are. It's x squared plus 4 and x squared minus 4. Now this is where you might get in a little trouble once in a while. You need to pay attention. Can I do more work? Well, this x squared plus 4 thing, I don't see anything, but look right here. Is it subtraction? Is this a square? Yes, it is. Is this a square? Yes, it is. Look at that. We can keep going, and now what we have, x squared plus 4, that we can't do anything with. But what is the pattern right here? X plus 2, x minus 2. Wow. Okay. Now this next one, well, that just looks way too weird. I think maybe this is too hard. Can I find 2 of something that are exactly alike that I can multiply? Well, let's start with y to the 4th. We already did that a while ago. Isn't that y squared times y squared? Doesn't that give me y to the 4th? then what will give me x to the 8th? X to the 4th times x to the 4th. Wow. Okay, now what do I do? Well, my factors are, let's change colors, x to the 4th plus y squared, x to the 4th minus y squared. Oh, that wasn't too bad. I thought it was bad, but it's not. But am I done? Oh my gosh, look at this. That plus I can't do anything with, but is this one subtraction? Is this a square? That's y times y. Is this a square? X squared, x squared. So now my factors are x squared plus y and x squared minus y. And don't forget the one that we started with, which is a very common mistake for us, is we forget the one that we started with. Okay. I want you to think about this for just a minute. Our first instinct is to put 3x, 3x, and 9 and 9. Why is that wrong? What did you forget to look for? G, C, F. And that's what will hurt us every time. When you had 9x squared minus 81, you should have divided both of them by 9 and put 9 out front. Now you have this. Can I work on that? Sure. That's got a negative. This is a square. This is a square. So I still have my 9 because that doesn't go anywhere. And now I have my pattern, x plus 3, x minus 3. Everything is about the pattern. Okay? We're going to finish up with a special case called perfect squares. And what do we say about this? Is really special patterns, because patterns is what we're looking for. And this one I don't worry about too much, because even if you don't notice it, you can still solve it. But I will say this. That's a square, isn't it? And you know that's 5 times 5. So what I want you to do is, if that's 5 times 5, I want you to try stab at 5 plus 5, x plus 5, and x plus 5. Now, why am I not doing a negative and a positive? Because the middle term is there, isn't it? If the middle term were gone and it was subtraction, then I would try my pattern. But this is another type of pattern too. So I want you to think about it. This is x squared, 5x, 5x, and 25. Now this time, did these cancel? They don't. So that's going to end up to be x squared plus 5x plus 5x plus 25, which is going to turn into 10. This is a pattern that maybe you'll just notice, but maybe even if you don't, you should be okay. Let's see if it works again. Is this a square? It is. That's 3 times 3, isn't it? Well, let's just try 3 and 3 and see if that works. Well, that's x squared, 3x, 3x, and 9. And when you add those two together, what do you get? 6x. So if I look up and I have a square right here, I need to ask myself, is 3 times 3 okay? And is 3 plus 3 okay? Just another one of those patterns that we need to get used to. So let's look at these. Is 144 a square? It is. That's 12 times 12. Well, is 12 plus 12 24? Oh, well then I have my plus 12, x plus 12. I don't have to go any further. Is this a square? It is 11 times 11. Well, is this 11 plus 11? Oh, well, I don't need to go any further. X plus 11, X plus 11. All right? So those are two of your special cases, and we're not going to call them special cases. We're going to call them patterns.